All right, so we're going to say after, some algebraic manipulation. So the answer for question 8 was, who wants to say? Okay.
X belongs to negative infinity.
Negative infinity.
To negative 1.
To negative 1.
Inclusive.
United with, you can say united.
And then exclusive. Negative, no, exclusive. Oh, we got the same.
Okay, right?
Negative 1/5.
Negative 1/5.
To infinity and beyond.
Infinity and beyond. All right, okay, so that is the answer for question. All right. Okay, I hope all of you got this. If you didn't, then we're going to check that in tutoring. Okay.
It's just one answer. I got that wrong.
Okay, question 9.
I got that very wrong.
Okay, let's do question 9 now, okay?
Wait, so can everyone remind me, see if I do it right?
Okay, Emilia? Okay, I'll show you later.
No, it's fine.
But you need to know how.
Yeah.
Okay. All right, question 9. We have x squared minus 5 over x is less than negative 4. Okay, so you can see that x cannot equal 0, so you need to exclude that straight away. And then we're going to multiply by x squared, right? Okay, so when you multiply by x squared, then you're going to have x multiplied by x squared minus 5 is less than negative 4 multiplied by x squared. All right? Can you see that if you multiply this side by x squared, then you're going to get rid of 1x, and then you're going to have only 1x on top? Okay. All right, and then I'm going to move this negative 4x squared to the other side. So we're going to have x squared minus 5 plus 4x squared less than 0. All right? And then we have a common factor, which is x. Can you see that that is the only common factor? So we're going to say x is a common factor of x squared minus 5 plus 4x. Close bracket, less than 0. Right? And then we're going to have x. And then in here we're going to have x squared plus 4x minus 5. And this is going to be an interesting one because can we factorize this in here?
Mm-hmm. Whoa, what?
Can we factorize it?
5 and negative 1.
5 and negative 1, all right? All right, can you see that? Mm-hmm. Okay, we haven't yet done something that we call polynomial. Okay, so when you do polynomial, you're going to be dealing with expression of higher degree. So you're going to be doing, can you see that up to here we have been dealing with x squared. Okay, but if you multiply x by x by x, then you're going to have x to the power 3. Okay, so when you do that topic, then you're going to learn that if you sketch things like this, then you're going to have a picture that looks something like that, right?
Wow.
Okay, so that's going to be something that we call a cubic polynomial. Okay, so that means that to find the solution for this, we draw this picture and then we do exactly the same as we did with the parabola. Okay, so I'm gonna do this, but keep in mind that we're gonna do that in detail later, right? Okay, so for now I'm gonna have to show you, and the reason why it looks like this because of that cube. Okay, x times x is x squared, but in here we have an extra x that you have to multiply by. So that's why you're going to have x cubed. So in other words, if you expand this, then you're going to have something involving x to the power 3. Okay, so I'm going to continue with the solution. And then, like I said, later we're going to do this in detail. So don't stress out about this question. Okay. So you're going to continue in here with that question. Okay, can you please draw the number line? Draw the number line, and then we're going to put the solution for this. So we're going to have 3 solutions this time. Okay, the first solution is going to be 0. Okay, so that if you make if you equate each one of these factors to 0, then you're going to have x equals 0, x equals -5, and x equals +1. Okay, so that's what we're going to do. So we have, let's say that this is -5, and then we're going to have +1 and 0. So this is 0, and let's say that +1 is somewhere there. All right. Okay, and remember that we made the restriction for x, and we said that x cannot equal 0. So we're going to put this in here. But we don't have any problem with +5 and -5, sorry, and +1.
But isn't it still like in circle because it's not equal to?
Yeah, good point.
So do we do closed circle and you can circle too?
Yeah, isn't it included?
Oh, okay.
Right, okay. And then we're going to draw that picture. Okay, so we're going to draw that cubic, and we're going to do it like this. So we're going to start from here, and then we're going like this, and then up there.
How do we know it's up?
Good question. So you just take any number from here, okay, and see if the answer is positive or negative. Okay, what I say is this. Yeah, because the picture can be the other way around, all right? Yeah. Okay. And I took a risk. I don't know, but okay, let's say. So if you take, for example, -6 and substitute it in here, can you please substitute -6 in here and tell me whether the answer is positive or negative? Because that will tell you whether you start from the bottom or from up there.
Does it matter what number you use?
It doesn't matter.
Substitute in? It could be anything.
Yeah. I put -6 because I really want to see whether I should start from here or from there. So you tell me if the answer is positive or negative when you substitute -6.
Negative.
What is it?
Negative.
Negative?
What number did you get?
Negative 42.
Yeah. Okay, so that means it's fine. Okay, so we're going to start from here. Okay, and then pay attention because this is the sort of new thing that you haven't done. Okay, we want the picture to be negative. All right? Okay, so we're gonna select all those sections for which is negative. So it's gonna be here, and it's gonna be there. All right? Can you see that? Because this is gonna be positive, and this is gonna be positive. Okay, so that means that our solution, because we want negative, so it's gonna be anything in that direction, anything between this, and that's it. Okay, so we want those two things to happen. No, because it's from here up to here only. Okay, so it's going to be that interval. The other one includes negative infinity. Okay, so to write the answer, we're going to say this. So x is I'm going to do it in long way first, is less than -5 or x is between 1 and 0. Okay, so that is the normal notation. All right? But if you want to do the set notation, then you're going to say x belongs to this set notation. So it's going to be all right, so it's going to be that set united, and this is interesting. So
the other coordinates together? It's like the other coordinates together?
yeah. Okay, and then we're going to say, can I need more space. Okay, and then we're going to say united with this interval. Okay, so that interval is equal to, what is it?
Open bracket 0.
So it's going to be open bracket 0.
And then positive 1.
0 and positive 1.
Yeah.
Yeah, that's it. Yeah. Well. All right. Okay. So I'm gonna say that you should be able to do the rest of this question. Okay. Question 10. It was there before. Okay. 11 and 12. Do you copy question 10?
No.
Okay. I can do it.
11 could be
Okay, so can you please copy this? Because I want you to do this question. But this, I want to do this question later. Okay, not now, because now we're gonna continue with this, and the next thing that we're gonna be doing is simultaneous equation. All right? Yeah. Okay, so question 10, 11, and 12 is to be done at home. For homework. By the way, the answer for this question in Canvas, so if you get stuck, you can have a look. Right? And later, I'm going to show why you're doing this. All right, so can I... All right, so next heading, can you please do simultaneous equation?
Is this an advanced or extension?
Still extension.
Oh, like the other one. So it's not doing advanced. It's just making it That's good.
Okay, simultaneous equation. Simultaneous equation. Okay, in this course, we're going to be doing something that we call linear simultaneous equation and nonlinear simultaneous equation. Okay, and I'm going to explain to you what simultaneous equation. We're going to have the linear and nonlinear. Okay, the first one is something that we did in detail last year in year 10. And the nonlinear is something that we did just a little bit when we did it online. All right? When talking about linear, Okay, in linear simultaneous equation, we're talking about, remember, we're talking about two lines. Okay, so this is line 1 and line 2. And we are finding, the point where they meet. That's it. That's all what we mean by linear simultaneous equation. Okay, so we do all the algebra just to find this point. Okay, so when solving linear simultaneous equation, all what you are doing is to find where these two lines meet. If the lines are parallel, obviously the system doesn't have any solution. All right? When we say nonlinear, we're talking about things like this. Sometimes we're going to be intercepting a line together with a parabola. I just mean that we're going to have 1 and 2 solutions sometime. Okay, so we're going to be dealing with parabolas together with a straight line. Okay, and when you have situations like this, we can have 2 solutions. Okay, sometimes we have only 1 solution. Sometimes you're going to have a situation that looks like this. So we're going to have exactly 1 solution there. And sometimes, unfortunately, you're going to have 1 parabola here, and then you're going to have this straight line going there, so we don't have any solution. Can you please stop it?